discuss today. It is restoration ecology, or different techniques which has been used in restoration. So basically, what is restoration, or different techniques that we are going to discuss in these 2 days related with restoration. I'll just give background related with the topic, as we all know that Earth is going through different changes because of human activities, and degradation which is happening at every level in ecosystems. You name an ecosystem and the degradation which is happening to the structure of ecosystem as well as the function of ecosystem, that is creating lot of issues. Maybe climate change is there, or we are experiencing a lot of changes in weather conditions. Species are disappearing from the planet, and so many different things, so many different issues are interconnected with this. Okay, so is there any solution to this man-made activities that we all are threatening the life which is there, and that is the only planet we have. There is no planet B, we used to say. So Earth is our home, and for all species also, it's home for them, it's habitat for them. And the human view related with the use of different resources, that should be ecocentric, or it should not be anthropocentric. We should not always consider us as the supreme user for whatever resources which are there. So restoration ecology, or the ecosystem restoration approach, which has been promoted since 1925, or earlier also in 18th as well as 19th century. Basically, there were many conservation activities. There were many activities which has been there for the restoring the degraded ecosystems. Okay, so basically restoration is nothing but bringing back the degraded ecosystem near to their natural state. So whenever we are talking about restoration, there are different practices, there are different strategies which has been mentioned time to time, or time by time. And 2020 to 2030, UN has declared this decade as decade on restoration, because awareness is there. Everyone knows what is happening regarding the industrial aspects, urban aspects, what is happening in our agriculture, what are the developmental strategies, what to do, what not to do, we know. But how to go for the sustainable development, and that is our aim basically. So the 2030 agenda for sustainable development, basically sustainable development is development that takes care of the future generations also. So it basically there are different sustainable development goals which has also been proposed by UN, that we should complete these by 2030. So to end poverty, to conserve biodiversity, then combat climate change, and improve livelihoods for everyone and everywhere. So all these 17 sustainable development goals which are likely to be met unless if we are not taking care of ecosystem degradation, or ecosystem degradation isn't stopped, and we are not up to restoring whatever we have degraded, ecosystem restoration is not undertaken. And this restoration should be hundreds of millions of hectares globally. It should not be like some pockets we are restoring, or it should not be like some small river stretches we are restoring, but it should cover hundreds of millions of hectares. And then only whatever 17 sustainable development goals which we are basically looking towards, they will be fulfilled. All these goals will be fulfilled. Okay, so there is insufficient political support as well as the technical capacity related with the toolbox of restoration in terms of public and private sector, and the funding that should be there in a large quantities. The funding that should be available, it was not basically not possible because of COVID, which hit us in 2020-21. So now, but the situation is changed, and you will be able to see if you visit the UN site for restoration. Then you will see many projects that has been undertaken, as well as the many hundreds of thousands of ecosystem restoration initiatives are there in place. So that is needed. That is the need of the time to achieve the restoration at a very large scale. So that is the aim for 2030 whenever we are talking about these SDGs. So these are SDGs, Sustainable Development Goals, that all the humanity should achieve by 2030. So you can see here in these goals, Sustainable Development Goals related with restoration, the clean water and sanitation, or good health and well-being. Then you will be able to see biodiversity, then innovation and infrastructure, where now everyone is talking about green infrastructure. Then 11th Sustainable Development Goal, which is talking about sustainable cities and communities. Then responsible consumption and production, all the green technology, or the life cycle assessment, industrial ecology, which is changing. There are a lot of green jobs which are available, and this basically restoration, ecosystem restoration will create hundreds of thousands of green jobs whenever the people or the NGOs or the industries or government, they will try to basically restore the ecosystems. Climate action is there, life below water, life on land, and partnerships for the goals. All these SDGs that might relate with the restoration. Okay. So basically, whenever we are talking about the ranking related with the environmental performance, as per Environmental Performance Index 2020, India has figured at the bottom of Environmental Performance Index of 180 countries. And this is the analysis which has been taken by researchers of Yale, Columbia University. So only handful of countries like Denmark is there, or United Kingdom is there. So they have the track to meet zero emissions goal by 2050. So carbon neutrality is there, or now everyone is talking about solar energy or green energy. So if we want to achieve all these sustainable development goals, and by 2050 net zero emissions, then we need to do a lot of strategies, work, research we have already done, but now there is a time to implement these strategies on field. And restoration basically gives us one beautiful platform for bringing back the degraded ecosystem near to their natural state. So it is like it's an applied ecology where you can use different ecological theories for bringing back the degraded ecosystem near to their natural state. Okay, so what is the historical perspective in this, or how the whole movement started? So conservation activities were there in 18th as well as 19th century, and the constructive efforts started in 1925 when the Ecological Society for Restoration was established in North America under the guidance of Victor Shepard. And the Nature Conservancy was also established in 1950, which played a very active role or very proactive role for the restoration of predator species in the American grasslands. So these two restoration projects or case studies are considered as success stories in restoration ecology, where American grasslands have been restored or predator species have been restored in these particular area. So how to go about the particular science, and what are the steps involved, or what exactly is the new field or the new approach the whole world is looking towards, is very important to understand, as well as this is again applied science, where you can apply your knowledge, you can apply your research on field, and that is why ecology or restoration ecology is applied. Then the ecological restoration, basically the tall grass prairie. Prairie is one of the grasslands in American or those cold countries you might have heard about. The prairie and steppes, these grasslands where they have been restored in from 1935 through the conservation movement. So Curtis Prairie restoration, it is an example of successful efforts of restoration based on ecological principles. So there are, basically we need to understand that restoration is not just beautification of nature. There are certain ecological principles involved. There is theory involved in this. So whenever you apply those theories, those scientific approaches for restoring the ecosystems, every time the restoration toolbox gets enriched. So each and every case study which we will discuss is unique, and it is adding up in the restoration toolbox. And the restoration toolbox is getting much more richer, you can consider, and there are many jobs available. There are many you can consider as research projects you can take. Funding is also available for restoring different types of ecosystems. Maybe river you can restore, or maybe forest, or maybe lake, wetlands, any ecosystem which is degraded you can restore by applying these ecological principles. So we need to understand that restoration is not just beautification. You just have planted some species of trees. Plantation is not restoration. Beautification of river is not restoration, but bringing back the structure of ecosystem which is degraded, and bringing back the function of ecosystem which is threatened by anthropogenic activities, that is considered as restoration. Okay, so taking view of all this, the Society for Ecological Restoration was formed in 1982, and this society is basically formed. The aim is to implement restoration activities. So different projects have been undertaken by government, by researchers, by industries, by NGOs, by individuals also. There are individual people who also have taken efforts for restoring their own land into a forest. You might have heard about many hectares of forests have been created by individuals. There are individuals also in India which have restored the forest. Okay, but the constructive activities which are based on ecological principles and socio-economic consideration of the people which are affected. So this society was established, and it is a growing enterprise in public and private sector, and it is covering many large and small programs of restoration. You can start your own venture also. There are students from our college who have started their startups in this particular field, where they are undertaking certain projects of restoring certain ecosystem, maybe river stretch or the lake or any of the ecosystem you can name. So restoration has been viewed as an ecosystem management. So it is ecosystem management which is preserving the nature, conserving the species, and it's like stewardship, or it's like ownership, that this entire planet belongs to me, and I have a right to get maybe clean air, clean water, like that. I also have a responsibility to make sure that the future generations will also get the quality of resources that I'm getting. So it is a valuable tool for analyzing community organization and ecosystem function. So with restoration ecology or ecological restoration, it is a valuable tool in that case. So there are many case studies we will discuss related with the restoration. So there may be forest, grasslands, freshwaters, wetlands, which are basically they are trying to restore the biodiversity, the ecosystem services, and this is for mitigating risk of global change, global climate change, and they also include exotic species invasions. Okay, so the restoration projects, whenever we are talking about, or the restoration, future orientation restoration, where what we see after restoration or the ecosystems we are trying to restore. So those ecosystems should establish themselves. They should be self-sustainable ecosystems, as well as they should not be dependent on human interference. Okay, like for restoring, there are many different types which we will be able to see related with restoration, but restored ecosystem should sustain themselves. We are not creating artificial ecosystems. We are creating sustainable ecosystems or self-perpetuating ecosystems. Okay. So future-oriented restoration should have multiple targets, multiple goals, alternative goals also we can design. And if there are any unpredictable endpoints, like we have started with some grassland, and because of our ignorance related with the past ecosystem, something different is getting supported by nature. So there are different unpredictable endpoints. So the restoration, future oriented restoration should consider alternative goals, multiple alternative goals, the trajectories for unpredictable endpoints. Okay. Then future restoration should focus on rehabilitation of ecosystem functions. There should be rehabilitation of ecosystem functions. And it is not just recomposition of species, or it is not just introducing certain species, the plantation programs, or reintroducing certain species, or cosmetics of the landscape surface. It's not beautification. Okay, restoration is not beautification, but it is rehabilitation of ecosystem functions. Okay, what are ecosystem functions? Can anyone tell any of the ecosystem? The basic definition of ecosystem, that is structural and functional unit of ecology. That is basically ecosystem. So whenever we are talking about structure of ecosystem, we are talking about the food chains, we are talking about the producers, we are talking about the consumers who are the detrivores. And when we are talking about function of ecosystem, that is related with cycling of nutrients, or you can consider it as energy flow, which is energy is flowing from producers to consumers to the secondary and tertiary consumers. So the focus is on rehabilitation of those ecosystem functions, and that is very, very important, that it's not just beautification of nature, but it's basically the rehabilitation of these different types of ecosystem functions. Okay. Then what are the principles of good ecological restoration? Okay, so good ecological restoration should be engaging, then it should be effective, it should be efficient. So there are three principles which we can relate with the ecosystem restoration. And whenever we are talking about the restoration, the human well-being is also very, very important to understand, along with ecosystem integrity. So along with the ecological aspects, the human well-being, the community which is dependent on the particular ecosystem, that community should also be considered. Their well-being should also be considered here. So I'll share this presentation so that afterwards you can check whatever these flow charts are there, where the linkage between human well-being and ecosystem services that has been mentioned here. And there is a restoration toolbox. Basically, restoration toolbox is nothing but the case study which we can take as a reference, and we have certain strategies for examples, the examples of the restoration practices that is considered as the restoration toolbox, which is getting richer and richer every day, because the restoration projects are at every level all over the world. Okay, so there are strategies for restoration. So there are three strategies which can be considered. First is passive restoration, or it is also called as natural recovery. So, when exactly to apply these strategies? So, in natural recovery or in passive restoration, basically, when the vegetation is destroyed and the soil is intact, so natural recovery is possible along with the natural succession, because soil is intact there in the particular area. So the damaging factor, if you remove, then the nature will take its own care, and the natural succession will be there, will take its own course, and that is the passive restoration or natural recovery, where human beings, they don't need to do lot of engineering work or lot of techniques. They are not required at this particular stage in passive restoration or in natural recovery, because when you will remove the causative factors which are degrading the ecosystem, nature will take its own care, and it will bloom, it will take care itself, and it will reach to the stage uh, before degradation. Okay, so this is a natural recovery or passive restoration. But many a times what happens, the degradation is at a very large scale, like mining. When you see mining or such activities, where the soil strata is almost disturbed. Okay, forget about the species, forget about the species composition. So in that case, nature is not, nature itself is not um, capable of restoring itself or healing itself. So in that case, human intervention is required, or techniques are required, so that it will support the natural succession, and in that case, full or active restoration strategy is applied, where damage have been intense or damage have been intensified, and that is the full or active restoration. Okay, but we always have to remember that the restoration is money intensive, time intensive, and knowledge intensive process. So that is why theoretical restoration, 100% restoration is not possible in any of the projects. So it is like we cannot mimic nature, because whatever created by nature or whatever created by God, we cannot create like this. But most of the cases, in most of the case studies, scientists have achieved almost 99% restoration. Okay, but it is a time intensive process, it is a knowledge intensive process. So for that, rehabilitation programs have been taken into consideration, because rehabilitation is also called as partial restoration. Okay, so rehabilitation is nothing but partial restoration. So to make one forest, which was like 100 years back, it may take some 500 years. Okay, but because creating a forest, it's not a it's not easy in terms of the species composition, the complexity which is there in the forest. But we can rehabilitate the forest, or we can rehabilitate soils or the rivers, and the rehabilitation is a promising strategy for restoration. And there are several advantages of restoration. So it converts, rehabilitation converts unproductive land into self-perpetuating ecosystems. Rehabilitation prevents further damage to the ecosystems, and like there are downstream ecosystems, the further damage is um, restricted or it is prevented. Then it reverses the negative trend of land degradation. So if the land degradation is there and the negative trend is there, then it reverses that negative trend, and it removes pressure on undisturbed lands, the rehabilitation. So there are three strategies which have been mentioned here. Basically, three strategies: passive restoration, natural recovery, uh, full or active restoration, and rehabilitation. Then the next point is plan of restoration. Okay, so what is plan of restoration? Basically, there are different steps which has been there in the plan of restoration, where we can have with synthesis of information, then restoration objective, the plan of action, the tools and methods, the monitoring, and the review. Okay, so this is applicable to your research also. Okay, so if we want to see how your research will go as you are doing your PhD, or as you are doing any research, this plan applies to you for doing your research. Like how it is applicable: when you start any research, you collect the information about your topic. That is, at local level, what type of research has been there. At national level, regional level, what type of research is there. Okay, at national level, international level, what type of research is there. So this is nothing but synthesis of information. You try to collect all the information which is applicable to your research, which is related to your research, and maybe from research papers you Google a lot, you basically read a lot of books. Then if it is a field work, then you collect the data about the particular ecosystem from the community which is there, from the people which are there. So synthesis of information. And in that case, in restoration, basically, you try to understand what was the ecosystem prior to restoration. Okay, what was the land use? Then what are the factors which has caused the degradation? And what are the components which has been affected by this degradation? So biotic components affected, abiotic components affected, what components affected? Then how these positive factors can be removed? How these factors can be removed? You can think of this in synthesis of information. And what is the biological potential of the site, or what type of species you should use for plantation or natural recovery, which will give you the most productive use of the land. Then what are the factors which will limit this establishment of species or growth? Okay, then what is the general successional sequence? So all this information you will collect. Okay, what aftercare is required? So this whole thing is called as synthesis of information. That is data collection. So it can be primary data as well as the secondary data you will try to collect. Then you will frame your objectives, restoration objectives, that after restoring this particular area, how it is going to be. The area is going to what type of area, and how it will be beneficial for the ecology of the area and the human well-being. Because restoration should always include human well-being. The community which is dependent on the area, that community should always be considered for financial benefits or economic benefits. Then plan of action. You might have heard about PERT chart, where you can make day wise, week wise, month wise plan for your research. So if it is a 5-year project, then yearly, monthly, what exactly and when exactly you're going to do, what activities you're going to do. This is called as PERT chart. So this is also applicable to your research. Then tools and methods, that is your methodology. What methodology you're going to use for your research, for the restoration also, what biological methods you're going to use, what physical methods, what chemical methods you're going to use, what engineering methods you're going to use. So in your research field work, what you're going to use, which softwares you are using. If you're doing lab study, what methods are available, how you will apply these methods. So this is tools and methods. And monitoring from day one is very important in the plan of restoration. What is happening to your ecosystem, because you are dealing with the live case. So it's not like you are doing certain lab assessment, you are doing lab study, you are dealing with the live case studies. You are creating the ecosystem, its structure, its function. So monitoring from day one is required. And review is also very important, that whatever strategies you are applying, they are going well or not. So from day one, if you're monitoring and you get to know that this strategy is not working, you can change your tools and methods, you can change your methodology. So this is the plan of restoration. And if you do your research according to this plan, okay, you will be a successful researcher. Whatever you have decided in your research, in your PhD, you will achieve all these things if you apply this plan for your research also. This is a part of research methodology, where what type of tools and methods, the entire plan can be discussed at a different platform, and a different subject is there, but it is necessary for you to understand what should be the plan of my research, that is also applicable to the plan of restoration. Okay. Then next point is, whenever we are talking about the rehabilitation, basically, so rehabilitation, it reverses the negative trend. And here one table which is visible to you, where the category of the physical and chemical problems that are associated with soil has been mentioned, or the problem has been mentioned, and what immediate treatment you can give, and what should be the long-term treatment. Okay, so if the problem is associated with the texture, then the coarse texture is there of the soil. You can add organic matter as the immediate treatment. But for long-term treatment, you should always focus on vegetation development. If the texture is fine textured soil, you can add organic matter. But for long-term treatment, you can always go for vegetation. Then the structure, basically, if the soil is compact or it is loose, then you can scarify or you can rip the soil, because soil moisture as well as soil aeration is very important for the growth of organisms, microorganisms, or the earthworms, which will basically gives the structure or the nutrients to the soil. So vegetation, that will be the long-term treatment. If the soil is unstable, the problem is related with the stability of the soil, you can add stabilizer or nurse the soil. Nursing the soil means you can add the nutrients which it can it miss. So nursing the soil or adding stabilizer. And the long-term treatment, as a long-term treatment, you can regrade or grow vegetation. If the problem is with the moisture, If the soil is wet, you can drain the moisture, the water, excess water, and the long-term treatment is also draining. If the soil is dry, then you can irrigate or mulch the soil. Mulching is nothing but adding the leaf litter or adding organic matter to the soil. And for the dry soil, you can basically grow tolerant vegetation, the vegetation which can tolerate the aridity or the dryness which is there in the soil. Okay. If it is the problem related with nutrition, that macronutrients like nitrogen and phosphorus that are missing, then you can add fertilizer. Always go for organic fertilizer. You can add lime as an immediate treatment. But as a long-term treatment, you can grow nitrogen fixing species, which will add up the nitrogen in the soil naturally. Then micronutrients, if it is deficient, you can add fertilizer, maybe immediate treatment, organic fertilizer. But for micronutrients, you might have heard about the vesicular herbicilar mycorrhizae or mycorrhiza. Most of the times have been used in restoration projects where inoculum or aggregation of these species, ectomycorrhiza or endomycorrhiza, have been added in the plants. It is a natural enhancer of different types of micronutrients which might supply the plants naturally. Okay, so the knowledge of ecology is very important here, that what type of mycorrhiza will support the plants, what type of ectomycorrhizae, endomycorrhizae will support the plants. So knowledge of ecology, ecological principles are very important here. Okay. Then if there is a problem with toxicity of the soil, that the pH of the soil is low or high, then you can add lime if it is low, and you can add pyretic waste or organic matter if as an immediate treatment. And for long-term treatment, you can grow lime as well as you can also grow tolerant species which can tolerate low or high pH. For high pH, you can add pyretic waste or organic matter, but always as a long-term treatment, you can grow tolerant species. Heavy metals, high than organic matter or tolerant plants. And as a long-term treatment, there should be inert covering. You can cover the soil, like mining have extensively happened in an area, and heavy metals, there is a concentration of heavy metals which is there in the soil. Then in that case, you can go for bioremediation. So there are many strategies which has been there, phytoremediation or bioremediation, which has been promising for heavy metals, removing heavy metals from the soil. Same applies with the salinity. If the soils are saline, you can irrigate the soil. Weathering is also promising option as an immediate treatment. But as a long-term treatment, you can go for the tolerant species. So these are some of the rehabilitative measures as an immediate treatment and as a long-term treatment. These are some rehabilitative measures, more rehabilitative measures which has been there. So you can assist the natural immigration process by growing certain plants which will attract birds, which will attract mammals, which will attract the consumers, the primary, secondary consumers, and they will take in their favorite seeds or their favorite germplasm. So this is considered as assisting the natural immigration process. Then after establishment of species by drilling or by cultivation, you can do hydroseeding or you can do cultivation of certain species. And species selection, what type of species you are growing is very, very important. Okay, then assist the accumulation of fine particles, because fine particles help in binding the soil particles. Then assess the accumulation of mineral nutrients. How you will do that by adding VAM, that is vesicular herbicicular mycorrhizae. Then assess the accumulation of nitrogen by maybe nitrogen fixing species you can grow. Assist the immigration of soil organisms, and you can assist in improving water holding capacity. You can introduce some earthworms, or you can introduce certain species which will improve the soil structure. Then you can assist in detoxification of the soil, and it is very necessary to regulate the speed of ecosystem processes. Different ecosystem processes, maybe nutrient cycling, maybe hydrological cycle, energy flow. You can regulate the speed of speeding up of the ecosystem processes, control weeds, that is unwanted species you can control, and you can permit invasion. Invasion should be there of the favorable species. Okay, favorable species are the species which will attract all other species, or here you can introduce keystone species where the keystone species will attract dependent species, the desired consumers, introduction of desired consumers. That is one of the rehabilitative measures. You can remove high impact stressors. Okay, any particular process which is causing high stress to the particular ecosystem, like the pH is high, or the temperatures are high, or the soil salinity is high. So you should remove all these stressors. These are abiotic stressors, high impact stressors. So you should remove all these stressors. Okay. So these are the rehabilitative measures. And you have this monitoring and review where you can judge your success of restoration project. So there are many ways with the help of which you can judge that you are successful in restoring the earlier ecosystem. For creating the ecosystem which was prior to disturbance, you should have one very important type of ecosystem with you, and that is reference ecosystem. So reference ecosystem is a ecosystem to that level you want to take your degraded ecosystem. So I'll give you one example of the reference ecosystem. In many forest restoration projects in Western Ghats, basically, sacred groves are considered as reference ecosystem. Okay, you know sacred groves, these are the patches of the forest. They are placed intact in the name of deity or in the name of God. People doesn't touch these areas, and these are called as sacred groves. So there are more than 2000 sacred groves documented. Undocumented will be many in Western Ghats. In Himalayas also, more than 5000 sacred groves have been found. Okay. So in monitoring and review, when you do the monitoring and review, there are three strategies that three strategies are there, which has been given by Society of Ecological Restoration in 2002. So direct comparison, where you will select certain parameters and they are measured from reference ecosystem and a restored ecosystem. So what is the species diversity of reference ecosystem, as well as what is the species diversity of restored ecosystem? That is considered as direct comparison. What is the soil organic carbon of reference ecosystem, as well as what is the soil organic carbon of restored ecosystem? So this is called as a direct comparison. Next is attribute analysis, where you are using qualitative data as well as quantitative data as well as semi-quantitative data, like frequency, density, abundance of the reference and restored ecosystem, as well as you will also get to know about its historical perspective from the people who are living nearby. And this is collected, the data is collected, and you need to judge that at what level you have achieved the goal. So the reference ecosystem is very complex ecosystem, but your restored ecosystem is not that much complex as the reference ecosystem. Then you need to do more work in that case. So attribute analysis uses quantitative as well as semi-quantitative data for the analysis of reference as well as restored ecosystem. Okay, and the third strategy is trajectory analysis, where you are basically trying to find out the trend of restoration, and here the data is used for statistical analysis, or data is represented in a graphical manner, and this is um, still under intervention, the trajectory analysis, because we know that restoration ecology is a new science. It is a new to maybe researchers and all, and this entire decade 2020 to 2030, scientists and various organizations are looking towards these aspects very carefully, and this is under what you can say, it is a promising strategy and it is under development, the trajectory analysis. So basically in this particular type of analysis, we are trying to understand the trend, and the data is collected by monitoring species interventions or the cost efficient techniques, like surveying during the peak seasons, or many pollinator networks. That is basically the strategies used. So this is a monitoring and review in restoration. And the central concerns in restoration, there are four central concerns which has been mentioned by NRC, that is National Research Council, and they have developed a checklist of questions for restoration projects during the planning and design, and in the post-restoration stage also. And there are all types of restoration projects. These concerns are applicable to them. So there are four concerns mainly: the product, feasibility and authenticity, scale, that is at what scale you are working for restoration, and the costs that are involved. Okay, so one by one, we will discuss these central concerns. So the product is basically your goal. So returning to a particular habitat or ecosystem as pre-degraded state, this is at different levels, you can several levels you can reach, the restoration can be practiced, but four strategies you can apply as a product. You can focus on habitat restoration, where once the habitat is restored, the species will return to the restored habitat, because habitat is not just the land surface, but it is a home for many species. So if there is a quality habitat, it will attract many generalized as well as many specialized species. Second is species or community restoration, where you are introducing certain species, or in many restoration projects, reintroduction of certain species have been considered, and the species restoration, basically it is very important to have the composition of the species, or the species composition is community restoration, that is nothing but enrichment planting, or you can add certain VM, that is vesicular, arbuscular, mycorrhizae. You can trying to get the ecosystem processes again to its place, that is considered as species or community restoration. Quality restoration is restoration of maybe BOD is degraded, biological oxygen demand is very high, and how you will get down that BOD readings, BOD results, your BOD results of the water analysis. That is the quality restoration of any river or any lake. And restoration of ecosystem and ecosystem services, where You are trying to restore the fundamental processes in the process of restoration. And this is basically the product. What exactly you want to achieve? You want to achieve the habitat, you want to achieve the species or community, or the quality, or the restoration of ecosystem and ecosystem services. Okay. Then, yes, this is habitat restoration, where the habitat is organism specific as well as land based. So, when you are talking about land based, it is its hydrology, it is its substrate is restored, and then the floral and faunal community appropriate to the land will be restored. It will automatically colonize. So, habitat restoration is the first step in every restoration program that we need to focus on. Then, next part is organism specific approach is basically identifying certain target species or group of species where the abiotic and biotic components are required to be there. And for this, you should ensure the availability of resources, because when you're planting at a large plantation is done at a large level, then the resources should be there to the particular plantation projects, or you have introduced certain species. So at in for a fewer amount of time, you should invest in making sure that the resources are available to that introduced species or that reintroduced species, unless and until that species is self-sufficient. Okay, so one has to ensure the availability of resources. Then the quality restoration, that is emphasis is placed on the restoring the quality of the system. As I said, the BOD, we want to improve the BOD or COD of the river. Okay. Then next is ecosystem service restoration, where you are talking about the fundamental processes which permits the ecosystem to functional. And there is a convention on biological diversity which talks about this ecosystem service restoration, where unless and until we will try to protect our biodiversity or restoration of ecosystems which are providing essential services which are conserving biodiversity, then we are not going to achieve whatever SDGs or the sustainable development goals which has been there. Okay, there are certain targets which we have decided to achieve by 2020 in Convention on Biological Diversity regarding the conservation of biodiversity or restoring fundamental processes of the ecosystems. So this is also applicable to convention. This convention involves all the countries, all the nations which are trying to protect their biodiversity. Okay. Then the next concern is feasibility and authenticity. That is how feasible it is to restore an authentic ecosystem. Look, you're investing so much time, you're investing so much money, because restoration is an costly affair. You will need a lot of money, a lot of resources for a restoration project. So, how feasible it is, right? How feasible it is, what is, and you have restored the ecosystem, how authentic it is. Who will tell that the restored ecosystem is authentic? Because the restored ecosystem is created by you. It is not created by the supreme maybe nature. So how authentic it is, how feasible. So authenticity and feasibility, you always need to make sure that your project is feasible and it is authentic. Okay, no one will question you about the restored ecosystem, that it is authentic or not. So to that level, you should take your project. Okay, and there are many success stories which we are going to discuss maybe tomorrow, where we will share some of the presentations regarding the case studies. Okay. Then the next part is scale of restoration. That is, at what scale you're working. So there are small scale restoration projects or middle scale restoration projects and large scale restoration projects. Okay, so when you should know at what level you are working. So small scale restoration project is just like plantation, or it is like introduction of certain species, which is called as a small scale restoration project. Middle scale is like you are restoring mining areas. Okay, mining. Nowadays, it is mandatory for every mine owner to have your restoration plan along with your proposal for mining. If you are proposing mining in a particular area, you should have your restoration plan ready, that I am using this land for mining for 25 years. What it is going to be after 25 years? That is a middle scale restoration. And large scale restoration is nothing but you are restoring rivers along with the wetlands. That is considered as a long or large scale restoration project. Like Ganga Action Plan will be considered as a large scale restoration project. Okay. Next part is cost and benefit, where different economic methods have been used here for understanding the costs and benefits which are arising from restoration projects. So there are 5-6 methods which I have included here in case of cost and benefit, cost benefit analysis. So first is market price output. So what you will do in this method, you will compare the fish catch from degraded ecosystem and restored ecosystem. And what fish catch, the money which you will get after selling that fish in the market, that is the market price output. That is basically calculated, and you can judge the success of restoration. You can get benefits, what benefits you are getting. Okay, this has happened in Chilika restoration. Okay, tomorrow we will discuss this case study where Chilika, which is one of the largest saline wetland in Asia, have been restored by Indian government from 2000, and this is considered as one of the success story of restoration in which the fish catch improved because of restoration. And there are many other interventions which also have been improved. There was a capacity building in the agriculture sector. There was a capacity building at youth and all. So those points tomorrow we will discuss. Then actual expenditure is nothing but basically when you're talking about restoration, that is the goods and services related to the use of that area. Like if the particular restoration project is used for ecotourism. Ecotourism is a tourism which is considered as environmentally sustainable tourism. And the restored area is used as a ecotourism project, ecotourism purpose, then that is considered as actual expenditure. And money which is getting generated out of this ecotourism projects is used for the benefit of the community which is dependent on that ecosystem. Third is replacement cost, where there considers economic benefit for a given good or service. So it is like to minimize the floods which are getting more intensified every year because of climate change, and less urban damage. What municipal corporation have decided to build a wall or to build a dike against the river, so that that wall or that dike will prevent the flood water reaching the urban areas. And what is happening here, every time because of floods, this wall gets washed away or the dike gets washed away. and there is a loss of property, loss of money also. But instead of that, if you protect wetlands, because wetlands acts like sponges, sponge basically they act like, and they are responsible for getting hold of water, flooding, which is maintained by these wetlands. So if the riverine vegetation or the vegetation, riverbank vegetation is taken care, wetlands have been taken care, then what is cost involved in wetland management and the cost involved in construction of wall, that is considered as replacement cost. Or another example can be mangroves. When the mangrove belt is intact, the loss of property is very less, loss of life is very less because of the cyclones. Okay, so that is the replacement cost. Then the travel cost, where you have restored the particular area, and to visit that particular area, people from all over the world, they are coming there. So travel costs are included, like what is the time and money invested by that tourist to reach to that restored site. So any person who is coming from Europe to visit Chilka, because a lot of people do visit these particular places. Chilka is a heaven for birds. So from Europe, any person is coming, any tourist is coming. So what is the time invested by that person to reach to Chilka in Odisha from Europe, and what is the money invested, that is calculated, and this is called as travel cost. Then the next method are hedonic methods, where after restoration, if the land price have increased, this has happened in Pune. There is one lake, Lakaki Lake in Model Colony, which is a restored lake. And after restoration, municipal corporation have restored this lake. And because of restoration, what has happened? The land price nearby the lake have gone 10 to 50 fold more. So these are hedonic methods. What was the land price before restoration and what is the land price after restoration? This is calculated. That is hedonic methods. And the contingent valuation, where basically this is considered as willingness to pay. That is considered as contingent valuation, where if I want to visit any sanctuary or if I want to visit any national park, there is some amount I need to pay as a maybe fee to get entry into the wildlife sanctuary or national park. So that amount is something 100 rupees or 500 rupees and all. So who decides this amount? Basically, there is a questionnaire which talks about the willingness to pay, that I will say to visit a Tadoba Tiger Reserve, I'll pay 500 rupees. But a people like layman, they will say that I'll just pay 10 rupees to visit to Tadoba, um, to um, to see tiger. Okay, so willingness to pay, that is method which is used for contingent valuation, and then the amount is decided. So if you go in zoological park, Rajiv Gandhi Zoological Park, zoo, any zoo, if you go, there is some amount, and that is decided by questionnaire in terms of willingness to pay. Okay, so these are the costs and benefits which are involved in the process of restoration, and how you will define restoration success, and what is the effectiveness of your project. So the three pillars are very important. Yes, these are the three pillars for most effective restoration. That is stakeholder success, learning success, and ecological success. So when you're talking about stakeholder success, There are aesthetic benefits, economic benefits, recreational benefits, and educational benefits that is considered as stakeholders' success. Learning success, there is a scientific contribution to the restoration toolbox. You have gained management experience, how to manage ecosystems, and there are improved methods which you have learned in the entire exercise. In ecological success, you have achieved the desired condition. There are ecological improvements. The ecosystems are self-sustaining and there is no lasting harm. There is no stress to the particular ecosystem. So these all things you should consider whenever you are considering most effective restoration. Okay. Then there are principles which one can address the landscape challenges, which include the learning in adaptive management, then entry point, common concern entry point. You can work at multiple scales. The multifunctionality of the ecosystems you should take into consideration. Okay, there are multiple stakeholders, the community is there, the scientists, the educationalists, the researchers, the students. So there are multiple stakeholders. Then you should have a transparent change logic, negotiated and transparent change logic. The money which is involved in that, there should be the clarification of rights and responsibilities. Then it should be participatory and user-friendly monitoring. You should apply. Resilience should be there, that you should change your strategy. You should be able to change your strategy if nothing is working. Then strengthen stakeholder capacity. That is another principle which can address the landscape challenges for the most effectively restoration, most effective restoration. Okay. So the different examples tomorrow we will take. Case studies we will take tomorrow for the restoration. Success stories we will take, but just for a small clip which will take you to the what exactly ecosystem restoration is. Just let me know the sound is visible or not.
In the next few decades, like we would lose our coral reefs, which will impact fish first, then fishers, then entire economies. But it doesn't have to be this way. What if I told you there's a solution? It's called ecosystem restoration. Healthy ecosystems regulate our drinking water and carbon, which are the backbone of life on Earth. All living things need carbon. Trees store carbon, so does soil, and seagrass in the ocean. Even the human body is 18% carbon. But as ecosystems become weak, they release carbon instead of storing it. Look at the soil below your feet. Healthy soil grows 95% of our food. But pollution, climate change, and pesticides are making soil less productive. And when yields go down, instead of restoring, we expand. Till more land, turning wild places into farmland, and pollute healthy soil. When we lose forests, wildlife is forced to come closer to humans, bringing what's called zoonotic disease, a virus that is passed between animals and humans, like bird flu, Ebola, and COVID-19. But there are some actions we can take today. Growing trees in cities would help to cut pollution dramatically. They would filter and cool the air, improving our health and reducing global warming. But trees can do more. Look at mangroves, for example. For each dollar we spend on restoring mangroves, we would earn $4 as they protect our coastlines from storms and floods. Building economies around nature will create jobs for the future, jobs that you could have. Restoring ecosystems will not be simple, and it will not be easy. But together, we can do it. We are calling entrepreneurs, thinkers, leaders in your family, school, and workplace to get involved. Can you do your part too? Reimagine how and what you consume. Recreate your relationship with the planet. Join Generation Restoration. Be a part of the solution.